Welcome grade 8. I would say good morning or good afternoon, but depending on what time you see this video will depend on what I should say. Today's brief demonstration is basically to help you understand a little bit more about how to make an insoluble salt and what a precipitation reaction is. And so what I'm going to do is do a couple of very simple precipitation reactions and describe what's happening in those reactions so that you have a better understanding of what you need to be doing when you get those questions in your textbook. So if you have a look at the first equation on the board, what I'm basically going to do is I'm going to add a solution of barium nitrate. This solution is dissolved in water, it's soluble. I'm going to add it to another solution which is potassium sulfate, again dissolved in water, so it's aqueous. Now when these two solutions mix, what should happen is that the positive ions from one of the solutions will come together with the negative ions from the other solution and we will form a precipitate, a solid. In this case we'll form barium sulfate, while the other positive ion and the other negative ion will stay in solution. And so we'll have potassium and nitrate ions still in solution. So let's have a look at that reaction first. So over here I've got barium nitrate. It's quite soluble. It is a little bit cloudy. There are some impurities in there, but that won't affect the reaction too much. And in this beaker I have my potassium sulfate. Both of them are soluble salts. However, when I add the potassium sulfate to the barium nitrate, we see a nice white precipitate forming. And if I want to collect that precipitate, it's very simple. All I have to do is take it over and filter it. And as it filters, the white precipitate obviously will be trapped into the filter funnel paper, while the soluble material will move through to the conical flask as the filtrate. So to understand this reaction a little bit more, let's break it down to the actual ions that are taking place or are in the solutions. So if we look at barium nitrate solution, it's made up of barium ions. Alright, these are with nitrate ions. So this is in one of our original beakers. In the second flask we had potassium ions and sulfate ions. When we added those two flasks together, as we said, we got this white precipitate. That white precipitate was our barium sulfate, so it stays together as a solid. And left over in the solution we have potassium ions plus nitrate ions. Now if we have a look at this equation now where I show all the ions, we can see that on this side of the equation we have potassium and potassium and nitrate ions, and they are still potassium and nitrate ions on the other side of the equation, and so they are what we call our spectator ions, and we can remove them because no reaction has occurred between those ions. And so what we're left with is the ionic equation, which is our barium plus sulfate, which gives us our precipitate, barium sulfate. And that is what you generally have to do when you want to write an overall ionic equation for the reaction. Okay, so that's one example of a precipitate reaction. Let's have a look at another example. Again, I've got two solutions on the bench. I have silver nitrate, which is dissolved in water, and potassium chloride, which is dissolved in water. When I add these two together, we'll form the insoluble salt silver chloride, which is a white precipitate, and we'll be left with potassium and nitrate ions in solution. Alright, so in this beaker I have my potassium chloride, while in the brown bottle I have silver nitrate. In this case I won't add too much silver nitrate just because it's expensive more than anything else, and hopefully the camera will be able to see the precipitate forming. Get that? So as I add silver nitrate, again you see a nice white cloudiness. That means that a white solid is formed, and if we need to get that white solid, again we can just filter the solution and we can obtain the solid that we need. In this case we can write an ionic equation. I'll skip the second step and go straight to the overall ionic equation. If you have a look, we know that this is aqueous, so we must have silver and nitrate ions. This is aqueous, so we must have potassium and chloride ions. Now if we have a look at this right-hand side of the equation, we still have potassium and nitrate ions in solution, so they are the spectator ions. So when we write the overall equation, we don't need to mention the potassium or the nitrate ions. So in this case, we have silver ions. We're going to react them with chloride ions, and we get our precipitate, silver chloride. Okay, one last example. Again, I've got two soluble solutions. The clear, colourless solution is potassium carbonate, while here, and be careful when you word these things in your exam questions, I have a clear blue solution. Okay? Clear and colourless do not mean the same thing. Colourless means there is no colour, clear means that you can see through it. And so when you describe the solution, it's clear colourless, clear blue, and this is clear colourless. So if I add my potassium carbonate in my left hand to my copper sulfate, I should see a blue precipitate form, and the solution becomes cloudy. I get this blue precipitate. From the overall equation, we see that that blue precipitate is copper 2 carbonate. So I start off with copper 2 sulfate, I added potassium carbonate, I got a precipitate of copper 2 carbonate, and I'm left over with potassium and sulfate ions in the solution. Now for those who want to try this, I'll let you at home try to do the ionic equation for yourself, and hopefully just by doing this very brief demonstration it may help you with the different questions that you have to do yourself from the textbook. But just remember, every time that you do a precipitation reaction, you're trying to make an insoluble salt by starting with two soluble solutions. And so you need to use the solubility table to help you. Okay, remember if you have any questions, please feel free to contact me through Google Classroom. Thank you.